Here we are. Here we are. Here we go. 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 When are we going to go? Okay. So what we're going to do is we're going to talk about the abacus. Obviously, because we always talk about the abacus, and I always talk about the abacus because that's all I think about. Or I'm doing like other things about the abacus. So what are we going to do? We're going to count on the abacus. When we count, we do 1, 2, 3, 4, and then we have 5. This is the value of 5. All the top beat has a value of 5. When we look at it, this is the value of 5. This is 5, 6, 7, whoa. Because just as we write, if I can find my this, there we go. Oh, this is nice. Okay, so just as we write, we have our tens, our ones, tens, hundred, thousands, 10,000. Oh, that's really good lighting right now. This is pretty cool. Hello, welcome. So this is 10. How do I know that's 10? Because just like we write, we have 10. And then we do 11. And then if I just erase this, this would be 11. So this is 11. How do I know? Because it's 1 and 1. What you going to do? So this is 11, and then we're going to continue on. So if we do 11, we do 12, 13, 14. How do I know? Because this is my ones, my tens, my hundreds, my thousands, and my 10,000. So when we look at it, we have our ones and our tens. And then when we're counting, we have 1. Notice this is the 1. This is also 1. All the top 1, all the bottom 1, 1. And then 5. Whoa. Oh, did I just lag? Well, let's see how we go. Okay. So we have 5, 6, 7, 8, 9, and then we have 10. So again, if we have 10, this will be 11, just as I wrote here, 11. Do you see the difference? So when we're looking at it, we have 11, 12, 13, 14, and then 15. 16, 1, and then 5 plus 1 is 6. 5 plus 1 is 6, and then this is 17, and then this is 18, and 19, and then we have 20. This is 20. Anybody have any questions? Let me know. So we have 20, 21, 22, 23, 24, and then this is 25. All the top beat has a value of 5. When we look at the top beat, this is the value of 5. So right now we have 26. This is my tens, this is my ones. So let me rewrite this, and it will look like this. 26. I have really bad handwriting, but for right now, that's what it looks like. If that makes sense. Anybody understand? Does everybody understand? Are we okay? Wow, there's a lot of people coming in and out. Thank you for following. Okay, so what's going to happen is we have our tens and our ones. So we have 26. When we look at it, we're going to do 36. Now I'm counting by 30, counting by tens. So when I look at it, this is 36. This is 46. This is 50. Again, the top beat has a value of 5. When the value of 5 is the top beat and always the top beat, and forever it will be the top beat no matter what. When we're looking at this, we have our ones, our tens, our hundreds, our thousands, and our 10,000. And if you look, our abacus mimics the way we write. When we write on the abacus, it's exactly the same as we write. Thank you so much for the likes. Thank you so much for the likes. Hey, the one of the best. Welcome back. All right, Nettie, welcome back. When we do 66, it looks like this when we write it out. It'll be 66, just like that. 66. That's what 66 looks like. So we do 67, 68, 69, and then 70. So let me rewrite this. This is now 70. So we have 7 and a 0. The question, anybody have any questions, let me know. So we have 7, 7, 0, and then 71, 72, 73, 74. Now, if I wanted to add the hundreds, let me do 200. So we have 274. Ooh, that's not right. That's 274. So let me rewrite that to be 274. You'll notice the difference between this column and this column. The difference between this column and this column is that there's a 5. So there's a 5. So it would be 5, 6, 7. This is 2. 2, we know that if we add 5, it will get to be 7. So this is 2. 1, 2. But we have to pay attention to, hello dog. we have to pay attention to the place values. We have our ones, our tens, our hundreds, our thousands, and our 10,000s. Good evening, Melinda. Welcome back. What we're talking about is just counting right now, and we're trying to figure out how to read the abacus. Yeah, so we have our 274, and then if I did thousands, let's say I did 8. So I do 8, 5, 6, 7, 8. A nice, always fun. Yeah, thank you. I appreciate that. I was actually going down this rabbit hole of making it vertical. I don't know if you were here for that, but I think I figured it out. So before I let me finish this thought, and I'll show you what I was talking about. So we have 8,274, and so this is how we read the abacus. Does anybody have any questions? Woo! Already. Anybody have any questions before I go into some adding and subtracting? We're actually going to be doing some regrouping, and and I was rearranging some things. Yeah. Hey, B, welcome back. Do you remember how to read? We're okay. Do we know how to read? Because I'm going to go into some some subtraction, doubled subtraction. Each color of the place value, or is it each column? It is each column, actually. So we have our ones, our tens, our hundreds, our thousands, not the actual color of the abacus. So if that confuses you, let's change this out. I saw it a bit, I was a bit distracted. Yeah, so let's start here. I'm going to use this ones because I have my indicator here. And then if you notice, because the new layout, you can switch me vertical on your phone, so I can be bigger instead of horizontal, instead of portrait, just so you know. So I think this is better because then you can make my face bigger. But yeah, you can put myself vertical now. You should be able to. Okay, so okay, so the one, right. So it'll be 4. So we have 4, 7, 5, 6, 7, 2, and then 8. This is 8. 5, 6, 7, 8. So each column is a place value, just as this is. Sometimes the colors gets confusing. Sometimes the color is a little bit overwhelming. But it is interesting. If I do change it to one of these, it's a little difficult to see, but it makes sense, right? Cool. So as we read the abacus, notice I start over here because I have this indicator. This indicator I use this as my ones place. So I can use this as my ones place, and then it indicates and it groups it for me. So this is a group. This is my thousands, and then this is my thousands and my millions. No, thousands. Yeah, millions. So then this is my decimal places. We have our ones. We have our decimal place that comes here. So that's where the decimal place, right? The decimal place doesn't sit on a place value. It sits between the two. So this is my tenths and this is my hundredths. Right. Does anybody have any questions? So if not, I'm going to go into some subtraction, if we're okay with that. I don't know if anybody has any questions. Anybody have any questions? Yeah, makes sense. Okay, good. Let me know if you have any questions. I know we have a few. I've been doing this for a little bit, so there's some old timers. All right, so I'm going to change to the colorful one because it's just easier to see. If there's any other questions, let me know. The first thing we're going to do is we're going to look at this question. 73 minus 29. Now, there was a few people, there was a person that said, well, why don't you just make it into a 30? So let me rewrite this. 73 minus 29. So can you divide? Yes, Eric, we can divide. But we can divide in a little bit. But for right now, I want to talk about subtraction. And this is kind of an interesting one. The reason why is because we're talking about regrouping, and so that was the thing. So one of the questions was, how do we do this? This is going to be a two-step equation, and I was trying to rearrange something, and then one person says, well, why don't you just make this to 30? What did they say? They said, why don't you make it to 30? Why don't you make this to 30? So like 30, so you minus the 30, so then it's like 7, 3, and then you take this away and it'd be 43, but you got to take away 1, so then it'd be 42. You could do that. You could do that. But then you don't do the thing called regrouping. So you kind of bypass regrouping. And what we're trying to do, even though this is an easy number, this number also provides practice on something bigger. So what that means is we're going to use the abacus, and we're going to subtract it. So we have 73. So we have 73. What we're going to do is we're going to take away 29. When we take away 29, we have to take away the 2. Now our question is left with 53. We have to take away 9. When we take away 9, let me rewrite it, and I'm going to write it over here. So if I had 53 left and I need to take away the 9, that's what we need to do. Thank you so much for liking the live. So what we're going to do is we're going to take away the 9. But notice we don't have any beats to take away the 9. What's going to happen is I need to find my formula. My formula is minus the 9 is equal to minus the 10 plus the 1. Minus the 10 plus the 1. This is the formula that we're going to do, but let me rearrange it. I am going to write the formula. If I need to minus the 9, it's minus the 10 plus the 1. Right? This is the formula that we need to substitute and put it into here. Again, I'm going to rewrite it. The only reason why I'm rewriting it so often is so that you can visually see what I'm trying to say. So 53, and what I'm going to do is I'm going to minus the 10. So I minus the 10, and I add the 1. So what we just did here is substitute 9. So that means I'm going to take away the 1 and then plus the 10. I'm going to take away the 1 and then plus the 10. Take away the 1 plus the 10. Notice I cannot take away the 1. So what do I do here? I need to take away the 1. To take away the 1, where is it? To take away the 1, I have to use my formula. Minus the 1 is equal to minus the 4, minus the 5 plus the 4. So what I'm going to do is I'm going to do this. Minus the 5 plus the 4. So I'm going to minus the 5 and I add the 4. And then I'm going to add the 1 because I still need to add the 1. So then my answer is 44. So I go back to here and I do 44. Did that make sense? I was trying to find like other ways, and I noticed that if I line it up like this, you could see that I want to minus the 5 plus the 4. So I actually rearranged my little flippy thingy. I only cut this one, but I rearranged it so then we can plus the 5. So if I did 4, let's see, what did we do? We did 4, and we want to add the 5. I'm sorry, we want to add the 4 to this 4. So we want to add the 4, what do? We have to plus the 5 and take away the 1. I'm a little confused. Oh, yeah. No, let me take that a step back, the 1 of the best, because I just jumped over, like, this is like intermediate stuff. Let me go back. But I was just thinking about it because one of my students had a question about it, and I was just answering it, and I was trying to figure out a way to. So what I was just doing as I was workshopping. Let me go back. Okay. So the first thing we're going to do is we're going to understand how to add on the abacus. So the first thing we need to do is understand when we add, we need to see if we have any beads. But thank you, one of the best, for letting me know. I do appreciate it. So the first thing we're going to do is we're going to do 8. When we add 8, you'll notice that we have 5 plus 3 is 8. So we actually, when we count, you could see the introduction of adding. So we have 5 plus 4 is, I think it should be 44. Oh, yeah. Sorry, it's minus the 9. It's minus the 9. Why would it be 42? Because it's 9. We did a minus the 9, so it's 44. Okay. So we're going back to here. When we look at it, we need to understand that we're going to we're going to pay attention to the add-ins. When we look at the add-ins, we always try to see what we're trying to do. That means that I feel like it's a bit complicated when I first started watching your videos. Not sure why. Yeah, that's what I was trying to think. Because I don't know. That's the one thing. Because why? Like what it is, it's a double. It's a two-step equation, and then I broke it out. So I can rearrange it. And then I try to make it more visual because this is what we're doing. This is the 9. Yeah, I don't know. I'm still trying to figure that one out. Because I'm trying to figure out how to make the two-step equation easier. I can't figure that one out yet. Okay, sorry. The one of the best. So what we're going to do is we're going to focus in on the add-in. When we focus in on the add-in, this one here, let's do this one. This is 5. So I add the 5 and I add the 2. When I add the 2, that's all I'm doing. I'm just adding 2. So now we see that our number is 7. And then again, if I clear my abacus, I'm going to do 6. So when I do 6, I'm going to ask, do I have enough beads to add 2? Yes, I have enough beads to add 2. Now, what happens when we don't have enough beads? Can it really be easier? I think it's just a different way of looking. I think that's what it is, right? Like, I think that's what it is. I mean, I was kind of happy about it, and I was thinking the way, like, if we wrote it vertical, some people actually made sense to write it vertical because you see, if I want to take away the 5 and I want to add the 1, or I do this one, I want to take away the 5, I'm going to minus the 4, I'm going to take away the 5, I'm going to add the 1. So I wonder. I'll see. I'm still workshopping it. It's still a new process that I'm trying to figure out. Okay, so the best. Where are we? What are the best? What are the best? Are we still with me? You're still with me? So what's going to happen is what happens if I need to do more? So if I do 3 plus 4, if I can't do plus 4, what do? Well, I do this thing where I have to add the 5. Why? Well, in school, good. In school, we teach the children how to add a 5. I don't know if you remember how to add a 5. Like, I don't know if you were taught how to add a 5. But in school, we were taught to add a 5. Plus the 4 is equal to plus 1. 1 plus 4 is equal to 5. Or 4 plus 1 is equal to 5, right? Or the other one is 3 plus 2 is equal to 5. Or 2 plus 3 is equal to 5. Now, in school, that's all they say, right? In school, that's all they do. But in Abacus, we're actually going to make our numbers work for us, right? We can't just have them like freeload off of us. What we need to do is we're going to isolate the variable. Why? Because what I want to do is I want to add this 4. To add the 4. So the question is 3 plus 4. Now we memorize our doubles. In Abacus, we don't need to memorize our doubles. In Abacus, we need to memorize our add-ins so it can be more versatile. Does that make sense? To make it more versatile, we need to understand how to utilize these concepts. So we could easily say, oh yeah, we just add 1 or whatever. But then you don't practice what the fundamentals are. So let's isolate this variable. You know what isolating the variable is because we do it in algebra. X plus 1 is equal to 5. Let's isolate the x. So we do x is equal to 5 minus 1. Now, let's replace the x to 4. So we have 4 is 5. Again, 4 and 5 is not equal. We need to make it equal. We do the minus 1. So what's going to happen is when we have the 3, there's not enough beads to add the 3. We know this concept. This concept is we need to add the 5 minus the 1. We're going to add the 5. So this is a little reminder. We're going to add the 5 and we take away the 1. Oh my God, you're counting something tangible instead of memorizing. Yes, exactly. So what's going to happen is we understand this concept, right? The reason why we need to utilize this 5 is because you can't break this 5. So what's going to happen is now we have 7. Did that make sense? One of the best. So when we look at this add-in, we can do this. It can be anywhere now. It can be very versatile, right? Make sense? So because it's more versatile, we can expand this question. We can do 2. 2 plus 4. It's a simple concept, but understanding the simple fundamentals, we can it will be able to scale to larger numbers. We don't need to do all the strategies like, I don't know, make a 300 by 700 or whatever. We don't need to do any of that. What we need to do is on Abacus, we just focus what we're trying to do. So if we did 2, so if we do 2 plus 4, right? Again, you can memorize your doubles, that's fine. Because we don't memorize our doubles. We know this concept. Remember the concept? It's this one. Plus the 4 is equal to plus the 5 minus the 1. So we just made it versatile. We can now use it in other locations. Because in doubles, right? Doubles is only one way. It's one ways and it's only addition. Can you do a minus double? No, you can't do a minus double because it just equals to 0. So memorizing the doubles doesn't help. Memorizing strategies like doubles plus 1, it won't help. But what this will help, because you're adding, right? You're augmenting the doubles. But this, we know that plus the 4 is equal to plus the 5 minus 1, no matter what. No matter what. So we add the 5 and we take away the 1. My answer is now 6. Does that make sense? So what we're doing is we're building a foundation. We're building something to, we're building something to be able to, it's a foundation. That's what we're doing. We're building a foundation. Great. Great. So what I was doing here, this one was more formulas, but really you only need to know 2 sets of formulas. How to make a 5. So there's many ways, right? You notice that there's all of these numbers is making a 5. If I want to add the 1, I'm going to add the 5. If I need to add the 3, I need to make a 5. If I want to add the 2, I can make a 5. So that's what this is. That's what these are. If I want to add the 2, so the question is 4. The question is 4, and I want to add the 2. There's not enough beads to add the 2. What do? I go to here. I need to plus the 5 minus the 3. So I plus the 5, just as it says here, plus the 5, and I take away the 3. And I just take away the 3 from here. And then my answer is 6. Right? So again, you understanding these formulas, you will be able to you can go anywhere with that. Okay, great. Yeah. So, but that's only one set. Now, here's the other one. Let's say we want to do minus. Is that another strategy? No, it's not. It's actually the opposite. So if I want to minus the 1, if I want to minus the 4, all I got to do is reverse the operators. I reverse the operators. I go minus the 5 plus the 1. So here's the question. If I did 8 minus 4, 8 minus 4. This is again simple, but there's no strategy. There's no memorization here. There's no memorization like doubles minus whatever. What we do is we have this. We have 8. Now I want to take away 4. Notice I don't have enough beads to take away the 4. I don't have enough beads to take away the 4. I know the concept of how to make a 5. So now what we're doing is we're building on top of the concept. So what's going to happen is if I want to minus the 4, I know how to minus the 4. I need to minus the 5, and then add the 1. And my answer turns out to be 4. And that's it. So now we just learned 2 ways. We just learned 2 sets of formulas. How to add a 5 and how to take away the 5. How to add a 5 and how to take away the 5. That makes a lot of sense. Yeah, right? And this is the fundamentals. You know how to use this, you'll be able to add anything. There's no other strategies you really need to know. I mean, you could use other strategies, but you don't need to. Yeah. Yeah. Bana, does that make sense? GG Bana. I don't know if you're still here. Yeah. So we're going to continue on. We can continue on doing more of this stuff, or we can go into, and then we could do like doubles, right? So we could do like double digits. Double digits the same way. And it doesn't matter. We don't need to like go through other things. Let me see if I can find it. Oh yeah, you know what? I'll do that. So we do 40, we'll do 41 plus 25. Right, we'll do that. How do you add, subtract bigger numbers with bigger numbers? How do you add and subtract bigger numbers with bigger numbers? Yeah, right? Bigger numbers like this? Or you want bigger? So, I'm going to add 41. Bigger. Bigger? Like, how many bigger? Oh, I had a bigger one. I think it was I don't have it with me, but like what? 7, 3, 4, 8 minus 2, 1, 2, 5? Like that? Do the first one. Leave me alone. Okay, I'll do the first one. This one? Okay, let me do that one. So, yeah. Okay, so we'll do this one first because leave me alone. Leave me alone had requested. So let's do that. We'll do 41, and then after 41 we add 25. This is a plus, right? This is a plus. So we remember, can we add a 2 here? No, we cannot add a 2. What do we do? Hey, O to base. So we're going to add the 2. To add the 2, we know our formula. Our formula is plus the 5 minus 3. So when we add the 2, it's equal to plus the 5 minus 3. Now, when we do it, we're focusing on this column only. This one and this one, right? We're only doing this. So when we're adding it, I'll do that. Plus the 5 minus the 3. Does that make sense? So I'm adding the 2. So I'm going to plus the 5 and I minus the 3. 1, 2, 3. That's all I'm doing because I'm adding 2. So now I go to the next column over and I need to add the 5. Do I have enough to add the 5? Yes. So I just add the 5 and we're done. So when I look, my answer is 66. Easy. $66. Yeah, you're welcome. So, but notice we used our formulas. We used our math. We used our plus 5. When we use our plus 5, it's versatile. It's scalable. So that's what that means. That's why we have this, and this is one of the foundation. So one of the best, this is really easy. We have 7,000, 1, 2, 3, 4, 7,348. Now the question is I want to minus. Well, the question is I want to minus 2,000. I want to minus the 2. When we look at it, again, we want to only look at the one column. When we look at the one column, do we have enough to minus the 2? Yes, we do have enough to minus the 2. All I got to do is take away 2. This one's 3. Do I have enough to minus the 1? Yes. So all I got to do is minus the 1. This one, 4. 4 take away 2. Do I have enough to take away the 2? Yes. All I got to do is take away 2. And then this one, final one, 8 minus 5. Do I have enough to take away the 5? Heck yeah. See how easy that is? Because we can see it. Because we can see what we're doing, we can take away the beads. If we have enough beads, then do it. If you don't, then you have to start utilizing the formulas. That's how that goes. Does that make sense? Okay, leave me alone. Do you have any other questions? Because you got to have more questions than just that. I really like your name. Leave me alone. But I can't because I like questions. Let me put a caveat on that. Any questions about the abacus? Do you have any other questions? Any other questions? Because if not, I'm going to continue on with adding the 10. Oh, I need to sleep. Oh, okay, leave me alone. Go to sleep. You should be leave me alone. I need to sleep. No, you're welcome. I hope to see you. In my next live. Just add and subtract, no multiplication. We could do multiplication. You want to do multiplication? We'll do multiplication. Yay, adding the 10. Ooh, 10. Okay, wait, sorry. 2, 2, 3, 8, 5. I'm sorry. That was this one. Okay, multiplication. Fee wanted multiplication. So let's do multiplication. We don't memorize our 12 times table, but we do is we only go up to 9 times 9. So the first thing we're going to do is let's do 45 times that by 6. So the first thing we're going to do, yeah, that's funny. So the first thing we're going to do is find out where our starting point is. The reason why is because we want to know what we're trying to do. So here is my multiplication question. I'm going to do it like this. There we go. Multiplication question. So my multiplication question, I count my digits. I have 1, 2, 3. So I'm going to be in the third place. 1, 2, 3. Why am I going to be here? Because I know I know my answer is going to be somewhere around the hundreds, right? So what I'm going to do is I need to do 6 times 4. 6 times 4 6 times 4 is equal to 24. So I add 20 and then I add 4. That's it. What's next? Next is 6 times 5. 6 times 5 is equal to 30. This, I don't have enough beats to add 30. I don't have enough beats to add the 3. So again, when we look at it, we're adding 3 to this 40. We're adding 3. To add the 3, what do I want to do? I want to add my 3. That's not it. I want to add 3. This is where our fundamentals come in. I want to add 3. To plus the 3, I need to plus the 5, take away the 2. So I plus the 5, and I take away the 2. My answer is, what's my answer? Phi. Do you know what my answer is? Oh, I was right. Yeah, good. Good. Make sense? So what's the answer? I don't know if he's still here. I just joined. Oh, I see. Oh, I see. Okay. So the answer would be, let's start it over. So the answer would be 230. That's what the answer is. Sorry, you're right. 270. Yes, thank you, Frank. Okay, what's going to happen is we're going to understand how to read the abacus. When we understand how to read the abacus, we do 1, 2, 3, 4, and then 5. All the top beat has a value of 5. Because it's 5, we have 6, 7, 8, 9. I just assume that when you said multiplication, I thought you knew you knew all the addition. Sorry, I'm sorry. So when we talk about this, we want to know what our place values are. So abacus actually mimics the place values. Abacus mimics the place values. So now I have my place value. I have my ones, my tens, my hundreds, my thousands, and my 10,000. Brand new. Thank you for the explanation. Oh yeah, no. Thank you for commenting because I wasn't sure where we were on the understanding the abacus. So this is 6. We have 5, 6. We have 7, 5, 6, 7, 8, 5, 6, 7, 8. Notice I could do 5 plus 3. And then 5 plus 4 is 9. 9. Now, how do we do 10? 10 looks like this. Wow, that looks very similar to this, doesn't it? Ooh, that looks very similar. The only difference is the columns, just as we write. Just as we write. So if I write 10, that's 10. 1, 0. If I do, thank you, Melinda. If I do 200, that's what it looks like. 210. Let me change this to another number. Let me do, I don't know, 5. We'll do 5. So 215. 200, 1, 5. Or yeah. So, and then we do another number. Literally blew my mind earlier today. Hey, Kobe. Welcome back. Okay. So, Fee, does that make sense? When we do 9,000, that's what it looks like. 9. That 9 looks very similar to the 10,000, right? That's 9. 9, 9. That's all this is. So each column only deals with 9. Great. So we do 9, 9,215. Yeah, thank you. No, thank you. So then what we can do is we can start doing some simple adding and subtracting. And that's where I had this. Now, in school, in grade school, in elementary school, in like grade 1 or grade 2 or whatever, we're very focused on the result. But oh, you're not a problem, one of the best. You let me know if you have any questions. Let me know if you have any questions. If you have any arithmetic questions. I don't do algebra. I don't do calculus. I don't do geometry. I only do adding, subtraction, multiplication, division. We can do decimals and we can do fractions, but fraction is just another way of dividing. Anyways, so going to the backstory, we are very focused on the result, but we don't want to be focused on the result. What we want to be focused on is the add-in. The add-in is the 2. So what happens is when we do 7, we have 7, and then we want to add the 9. Add 2. Adding 2. 1, 2. This is the 2 beads I want to add, and that's it. Yeah, you can divide with this. We didn't do it. Have you? I'm sorry, but you have people you can refer. Yes, I do have people that I can refer. Yes, you're absolutely right. I know somebody that does chemistry. I know somebody that does trig and pre-calc and anything nursing math. Hello, A. Just stop by to say hello and thank you for what you do. Oh, thank you, A. Oh, Kobe, this is very cool. I love chemistry. Oh my God. Yeah, there's a person I follow. Her name is Professor TK. She does chemistry. I think she also does nursing chemistry. I'm not sure, but there's a professor that does chemistry that I follow. Let me know if you want her name, Colby, and just send me a DM. But yeah, and she does like all these questions, and I'm like, she does like moles. I was like listening to her for a little bit. I mean, I remember chemistry, but it's been so long. But she talked about physical chemistry, I believe. Yeah. Okay. But yeah, you're absolutely right, Melinda. I do know people. I know people. Like the professors and the teachers, we kind of, I feel like we're getting up there. Oh, thank you. Thank you, Faith. Thank you so much. I appreciate that. I just really enjoy talking about Abacus. But then the funny thing is when I'm not talking about Abacus and I'm like kind of by myself, I'm kind of like, no, I'm kidding. What I do is I create worksheets for Abacus. And so I was actually in the middle of doing some mazes and then updating my flipping. I updated my little flipping formula thing. Okay, so about adding, when we add, okay, so here is the plus 2. So if we do plus 2, we understand how to do plus 2. The next one is to do a plus 3. So plus 3 is also easy too, because we just look at the amount of beads we have. But there's only so many questions we can use, right? So this is 5, so I'm going to add the 5, and then I want to plus the 3. That's all this is. I want to plus the 3. All I got to do is see if I have enough to add 3. 1, 2, 3, and then I add the 3, and then that's it. Hey, Olivia. Yeah, okay. So then our answer is 8. Again, if I did another question, let's say I did this one, 3. The idea here is 3. So when I add the 3, and then I add 6, plus 5 plus 1, and I add the 6. My answer is now 9. But notice, I'm very focused. Do you sell Abacus workbook bundles? Not yet. Not yet, but I will be. I only sell the Abacus separately, but it's only the colorful one, and I only have the 7-column one. If you wanted the 13-column one, you might want to try Daiso. Daiso. I don't know if you know what Daiso is. Daiso is a Japanese like dollar store, but now they're like $3.50 or whatever. It's spelled Daiso, or you can find it on Amazon. I think there's some in TikTok Shop. There's a few people that do sell it on the TikTok Shop. I've been trying to get mine on TikTok Shop, but I can't figure out how to get a document for something. So that's what that goes. But yeah, but I do sell like these flippy thingies, and I do sell my worksheets and my workbooks. They are available either on my website. If you want it downloadable, it's available on my website, or you can find my name. That's my name on Amazon. So, but yeah, this one you can get at Daiso. This one is nice because it's big enough for bigger numbers, and it's small enough because you're not going to get really that big of a number. Even because this is already 13 columns, so you have 13 digits that you can utilize. If you want to track the national debt, You could get a 23 column one. But I don't track the national debt, so it doesn't matter to me. But yeah, there's this. And it's big, it's long. But the same concept. It's still the same thing. We still have the top beads and the bottom beads. We still have the indicator. We still have the dot indicator. So you could choose any of these indicators as your ones place. And it doesn't matter. It's all the same. You just make sure. It's just the amount of digits that you have. So back to here. Oh yeah, so then this one specifically, this book was meant for preschoolers because I wanted them to, and I wasn't thinking that anybody else would enjoy it. So now I'm actually making more workbooks to be for all ages. This one was, you added the question, there's a question in the back, and then you would have to find the answer, and then you would have to cut it. So that's why there's pieces here. This was part of like up here. And thank you, Olivia, for liking the live. Thank you, Mason. Thank you, Metro Max, for joining. Okay. You guys. All right. Do you guys have any questions? Maxon, Olivia, Colby, one of the best. Melinda's always going to push us to like multiplication. All right. So plus four doesn't have a lot of numbers. What's going to happen is we're going to add the 4. What's going to be? So it's a 5. We're going to add the 5. Oh, that doesn't look good. 5. I add the 5. Right? We add the 5. I'm here. If you notice, I have this indicator. This indicator is my ones place. So my ones place is where I have my dot indicator. This is my label. You could choose this one, but I choose this one. My dot indicator is my ones place. And now all I want to do is want to add 4. So I am going to add 4. And there we go. My answer is now 9. Hi, Crafty Mom. Welcome. So what we're doing is we're adding simply on the abacus. Yes. And so if you know how to add, you will know how to subtract. So here we have 2, 1, 2, and then we take away. We take away means that we're only going to move the 1 bead down. Welcome. How do you do division? Why? You want to do division? See, I'm 25. Yes, I would love a preschool work. Really? Definitely for the, yeah. That, you're so silly. You're so silly. So I have it here where there's like color by number. There's a color by number. And then remember we did the bead recognition? I was going to do this one for the bead recognition. This one where we did a pixel art. So I had it where there was like, they have to know what the numbers are, and then they would have to like figure out what the number is. The reason why I did this way was because, you know, you see the number and then they would have to realize what the number is. So yeah, I'm 36 and I would like the preschool book. You guys. He's right. I can find people that are like me. You guys are all just like different versions of me. I love this stuff. Thank you. Thank you. I appreciate that. Okay. So again, yes, we can do division, but not right now because I think we need to go a little bit about subtraction and multiplication. After subtraction and a little bit of more addition, we can go into multiplication. And then if there's time, then we can go do division. It just depends. I'm a grandma. I love to show off your abacus. Yeah, really? What kind of abacus is it? Is it a 1 bead on top and 4 beads on bottom, or is it a 1 bead, 2 beads on top? So it depends. Is it a 2 bead on top, or is it a 10 bead? That's another thing. If it's a 10 bead, we would have to do some modification. The 10 bead, this is a Chinese abacus, and the Chinese abacus works so this is what it is. So let me show you how this works. It works very similar to the Japanese one. Let me move my pig. There we go. It's very similar to the Japanese one. Japanese, I don't have the brain power to learn division right now. I'm half asleep. Yeah, you know, it was a very exciting day for Colby. I'm surprised that you're still walking around. I needed a little nap after that. All right. Crafty Mom. Now, for Crafty Mom, the difference is just the amount of beads, but it works relatively the same way. The Japanese abacus was before the Chinese abacus was before the Japanese abacus. The Japanese, like they always do, is they make everything more efficient. But you'll see that there's a little redundancy in the Chinese one. When we count 1, 2, 3, 4, 5, in the Japanese one, it's the same thing. 1, 2, 3, 4. But 5 is this. Hello, hello. Hello, hello. So this is 5. Now in the Chinese abacus, we are going to have to do an exchange. Because this is 5, we're going to exchange it from this one top bead like that. That's all we're doing, is we do an exchange. We don't do anything else but an exchange. The reason why is because we want to count higher. We do 5 and then 6. So we have 5 and 6. 6, 7, 8, 9, and then 10. So now we have 10. We have a 5 here. What do? We have to do another exchange from 5 to 5. This other top bead is also 5. So, oh my God. Okay, so what's going to be, what's going to happen, I'm going to exchange it again for the 10 over here. The reason why I do an exchange, so that it makes sense with the place value. If you notice, if I do this, this breaks my brain because it doesn't make sense, because we had the place value for a reason. So what's going to happen is we do an exchange, we do 10, so we do that. That is why it's a little redundant. So when we talk about it, when we do this, this is 10. This is 100. So we have to do another exchange. We go from here to here. So you have to remember to do an exchange. But they're still the same formulas. You still need to, if you had 4 and you add another 4, you still need to plus the 5 minus the 1. You still need to do the formulas. Plus the 5, take away the 1. And then your answer is 8. With the Chinese version, is the decimals the same? With the hundreds, in the Chinese decimal, there is no indicator, so you could choose whatever you want. But yes, it is exactly the same. It's a decimal. So whatever you do on the abacus, however you write on the abacus, is how you write on the. However you write on piece of paper is exactly the same on the abacus, whether it's a Chinese abacus or a Japanese abacus. The difference is those abacus that goes horizontal. I don't know how that works, because our place values are not horizontal. So you know how there's the 10 bead, there's like 5 beads on one side and 5 beads on another side? And so then there's like a horizontal. I don't know how you would figure where your tens, your ones, your tens, your hundred, I don't know how you figure that out. Because our decimal doesn't, our number system doesn't work horizontal. Our number system works vertical. So this makes sense to me. So whether you're on the Chinese one or the Japanese one, it doesn't matter. The decimal and the place value is still the same. That's my favorite midnight math lesson. Hi, Eve. Welcome back. Welcome back. You guys. So what we're doing is we're just comparing the Chinese abacus and the Japanese abacus, and it is the same. It is the same except for a little redundancy, but yes, the plate decimal points is exactly the same. Thank you, Fee, for the question. That was a very good question. Any other questions? Anybody have any questions? So we're going to continue on doing the plus 5, plus 10. No, we did do the 5s. We're going to do the plus 5. I'm terrible at math, and I'm here. I'm mesmerized. Oh, you're mesmerized, right? I'm so happy you're in my FBA. Sophia, that's funny. Right? No, but that's what I'm saying. Crafty mom. I truly believe that if we just had the kids to do it, with a concrete item like this, it would make sense. Now, I would say this specifically because there are others, right? There are others. There are others, manipulatives, right? I'm imagining looking at them vertically, horizontally. Yeah, right? Vertically like this doesn't make sense to me. And I'm like, that doesn't make sense. How do you know what your place value is? Anyways, so yeah, you'd have to like turn your head. I'm like, oh, okay. Anyways, but yeah, what I'm thinking is like in school, I don't know how old everybody is, but I never had these when I was a kid because that's how old I am. I had to memorize my stuff. Anyways, so what's going to happen is like we're showing the kids, we're showing the students. I don't know if you guys had to do this, but we're showing the students how to utilize these blocks. I'm like, okay, great. But the problem with these blocks is it doesn't tell you about place values. It just tells you about the quantity. So if I want to do 10, I can do 10. Like I have to do a block. But then I have to do a trade. I have to do an exchange. I have to do an exchange, right? So if I did 10, I don't know. I have to count it. This is crazy. Okay, there's my 10. So if I had 10, I have to exchange it for this. So they have to do that exchange. And then they would be like, oh, that's 20. Yeah, I had those blocks in school. Oh, yeah, see, you're young. I didn't have these. These are these are young. This is for young people. So, but what I'm saying is you guys were taught this, right? This was what you were taught. But the problem I see is it doesn't grow with you. Whereas the abacus grows with you. It can go, like my kid is in grade 6 and he still has a little bit of problems with like his multiplication and his division. I said, you know what? Get your abacus out and let's do it. I don't remember using them, but I definitely remember. Oh, right. So that's the other thing. The other thing was some teachers don't know how to use it because it's a little bit overwhelming. One, it's overwhelming. Two, the maintenance, right? Every child will have blocks. And then what if they like shove it up their nose or eat it or something? Then you're screwed. So anyways, see, it says here, not suitable for 3 years and younger. Anyways. So that's the thing. Like, and then there's this whole exchange thing. But they're starting to do more Common Core now, where they're doing more physical stuff, more math manipulatives. But I don't see why we don't go back to the abacus. So when we talk about it, right, we can see how we can add and subtract. We did the simple adding. So if I did 2 plus 2, we don't memorize our doubles. What we do memorize is how to add. But we always have a conversation, because why do we have, that was one of the things. I was reading an email. She was a math major and she went from high school to college as a math major, and she was like, yeah, I got this. This is not a problem. And she was talking about how 7 things that she wished she knew was common. You know what? Abacus is actually Common Core, in my opinion. Unprofessional, correct opinion. My teacher uses margarita necklaces and she cuts them and represent. Oh, yeah. Oh, but this is Common Core. I'm telling you, this is the greatest thing. Okay, wait. So let me finish my thought. It was, she was saying, in math, in school, in high school, like elementary school and in all this stuff, they never was taught critical thinking. They were just like guided. But in abacus, we have to critically think, do we have enough beads? So the question goes, here's a simple question. Let's do 4 plus 4. It's easy, right? We don't memorize. Don't memorize 4 plus 4. What we do memorize is abacus is Common Core. Heck yeah! Yeah, it is. Because Common Core is talking about as a whole. So the question is 4 plus 4. Let me find my, yeah. So we have 4. We have 4, and I want to add another 4. Now notice I don't have enough beads. I feel like children will learn basic faster with the abacus. Yes, exactly. Yes, exactly. To be able to do, and that's what I think too. And so, I want to add the 4. So I add the 4. There's not enough beads to add the 4. See, that's the question. Now we're having questions. We're having a conversation with our questions, because we need to critically think these things, right? When we critically think these things, it makes sense. So here, do I have enough beads to add the 4? No. The question is how do I do it? Now, if I want to add the 4, remember we were taught 4 plus 1 is equal to 5. This is part of Common Core. But we're going to supercharge this, right? We're going to supercharge this. And this is supposed to be a lightning bolt. I got to get better at drawing. We're going to supercharge it. What are we going to do? We're going to isolate our variable. Isolating the variable is a algebraic term, right? We're going to isolate the variable, and we're going to say 4 is equal to 5. 5 is too big. We take away the 1. Looks like a lightning bolt to me. Eve. So what will happen is we're going to take our 4 and we're going to substitute this equation. Why? Because we want to add the 4. When we add the 4, we need to plus the 5 minus the 1. So that's what we're going to do. Here's a little reminder. We're going to add the 5 and we minus the 1. So my answer is now 8. Did that make sense? Thank you so much for the rose, Crafty Mom. Did that make sense? Is that all right? So my answer is now 8. So what we just did is we understood how to, wow, I get it. Yeah. But it gets better. It gets better. The flippy thing is a new thing. Yeah, well, I updated it, but no, the flippy thing is not I've had it for a little bit. Okay. So, but the flippy thing is new because I made it more vertical. So, Yeah. Oh, yes. The vertical flippy thingy is a new thing. Yes, I was working on that. And yeah. Yes, you're right. You're absolutely right. Vertical flippy thingy. Okay. So let's come back. Let's come back. Let's do 2, right? It's easy. We know how to do 2 plus 4, but the idea to this is understanding the fundamentals. It's understanding the basics. It's understanding what we're trying to do. When we do the 2, here's my 2. I want to add 2. There's not enough beads to add the 2. You earned a follow from me. Ah, thank you, Fee. Thank you for the follow. So we want to add the 2. But then what are we going to do? We know what we're going to do. We don't have enough beads. What do we do? Because we're adding a 4. We know this. We just do it again. Plus the 5 minus the 1. That's all we do. Does that make sense? Plus the 5 minus the 1. And then my answer is 6. My answer is 6. That's it. I'm a little jealous that I have to live vicariously through my kids. It's trust the process. Oh yeah, exactly. Trust the process. Marry the process, divorce the result. But see, the thing is, people will come in and be like, well, why don't you just add a 10 or make a 10 and all these other strategies? I'm like, you could learn all the strategies. That's not a problem. You can learn all the strategies, but I think there's more strategies than the formulas that we need to memorize. There's only 4 sets of formulas that you need to memorize: how to add a 5, how to subtract a 5, how to make a 10, and how to take away a 10. Those are the only formulas that you need to know to add and subtract at scale, which is like crazy. It's crazy to me. You just need to be very versed into it. That's all. You need to understand how to make it into a 2-step problem, into a 2-step equation. And a 2-step equation will practice for algebra. When you start substituting and you start isolating the variable, this is all practice for algebra. Abacus is the gateway to complex math. Abacus is the gateway to complex math. Why? Because Abacus provides a foundation, so then it goes back into your long-term memory. Then you can use your working memory for your newer, more complex math stuff like calculus and algebra and trigonometry and sine and cosine and derivatives and statistics. But you'll know the fundamentals if you know these formulas backwards and forwards. You will know these backwards and forwards. You will be able to go way ahead in understanding. You won't need. Yeah, you won't. It won't be that difficult, if that makes sense. But yeah, but it is a lot about trusting the process. But understanding later down the line, it will help. Just right now, it's the thing. Do you teach Abacus as your day job? I do now. My day job is trying to get this business off the ground. I have some tutoring. I have some books. I have a few books that I have published. My name is Lynette Young, and you can find me on almost all of the social medias. I have a YouTube channel. So we'll see. We'll see if I can get this off the ground. But my previous job was a computer programmer. So I did like web development and application stuff. But then I got laid off, and then now I'm here. But I didn't just fall into Abacus. So just so you know, I've been teaching Abacus on the side for 20 plus years. I have 3 boys. They've all gone through Abacus. Oh, good. You're a computer. What languages did you do? I did front end work. So HTML, JavaScript. Some of the stuff was we did Angular on one of them. One of the applications I was on, we did Angular. I started it a long time ago. I don't wanna, yeah. But I've been teaching Abacus for 20 plus years now, and I'm just now starting to get it into. I'm popularizing Abacus. I'm trying to make it public friendly. Right now, I'm working mostly on Python, but we're starting new projects soon in C. Oh, that's really interesting. With the C, you're going to have to do a lot of compiling, because in Python, you'd have to do so much compiling. It's more scripting. So that'd be interesting. Python is a good one for data processing. Yeah. C++ and Python here. Yeah. Okay. So what is it? Are you guys building what kind of applications would you be building? See, that's the other thing, right? Building applications. The one that I used to work on was a education I did it for education school. And so what we did is we tracked students as they gone through, and mostly it was high school students that needed a second. It was a charter school, and what we did is we tracked the students. We tracked their. It's like Power School. That's what it was, kind of comparison to Power School, but we also had like testing as well. We had tests. We provided tests within our software, so. But now my day job is trying to get this off the ground, and I'm trying to get my abacus and up and going, and we'll see. I have a year. If not, then I have to go look for a job, which I don't want. Haha, the American dream. Yeah, the American dream is to figure out how to get abacus out into the public, how to make it public friendly. Wasn't that what it was? Public friendly. How to popularize abacus, how to make it into more mainstream. That's what I want to do. So we have the plus 5 here. So when we add the plus 5, the next thing we're going to do is how to make a 10. The reason why we want to make a 10 is it's like carrying over or borrowing. So when we carry over and borrow, what does that mean? Well, one of the questions we have is 9 plus 9. Let's do 9 plus 9. I think this method is much better than teaching my niece to count with her toes. You know what? Counting with toes and fingers are still just as good because it's concrete. My son just said he wants to learn the abacus and he's 8. Yeah, he can learn the abacus when he's 8. And if he's open to it, then I have. If you're okay with, the first thing I would do is if you're okay with themed, right now, this is what I have available. You could look at my TPT store, but I don't think it's still just preschool stuff. You can pick and choose. You know what? I'll take that back. If you want to, you know what? You could go to the TPT store and you can get the back stuff. So there is the one where you do I think it's lesson 9. Look for the ones that says plus the. I have to go look it up and see if I grouped it. But what it would be add the 1 and you do plus the 1 all the way to minus the 9. You could do that. Ooh, that's a good one. So then it still puts in like the formulas, and this is not formula driven. After he understands how to do the adding and subtracting on the abacus, then I would have him go into I'd then have to go into this one. Is your book still available? Yeah, this one, the preschool one, that's available. But it's got extra words. It's got extra pages that I don't know if you could, yeah. This is still available on Amazon, and if it's on my TPT store, and it's also on my website. So, but the one on my website and the TPT is digital. Early mainstream math really emphasizes counting with 2 hands. In ASL, really, you can count on 1 hand. Yeah, but I don't know how you do it in ASL. I know you can. But I don't know how they do it. I know, like, anyways. Yeah. You can. I do a little. I do a little bit when we start talking about the plus 5. Why? Because sometimes the kids don't understand. He will be fine. Oh, I do suggest though, if you want, you can get this one, but the colors might be overwhelming for him, or it just might be too much. You might want to get this one because then this will grow. I can count to 25 minutes. Oh yeah, it's pretty easy to learn once you learn. Yeah. I mean, when I was working on my worksheets, I was looking into it. You could use the 13 column one. You can get this from Daiso, and that's what this is, Daiso. Or you can go on Amazon or TikTok. I know TikTok Shop has it. There's some vendors that sell the 13 column one. I sell this one, but that's on my website. I haven't figured out how to do it on the TikTok Shop yet. That's the hardest set of numbers. Everything else is very repetitive. Oh, interesting. Yeah, you know what? Abacus is very repetitive too, if you think about it. We only do to 9. We only go up to 9. If you think about it, we go 9. That's 9. 9, 9, 9, 9, 9. That's it. 9, 9, 9. And then there's decimals, right? There's a decimal right here. That's all it is. Right? So we have decimals, or ones, tens, thousands. So this is 9. 99,999.99. That's it. The hardest part for kids is 3. Really? That's interesting. I'll get the brown one. Yeah. My brain naturally, I'm sorry, complicates it so fun. Where's the decimal in the 13 column? The 13 column one? Any one of them. So if this is my ones, my decimal will be the next one over. So it'd be between the tenths, right? My indicator and my tenths, my ones and my tenths will be right here. Or it will be over here, right? If my ones, if I did that, yeah, my ones, my tenths. So that's what it is. It doesn't matter. You just need to choose. You just need to choose your indicator. As long as you choose your indicator, then the next column over would be your tenths. So then anything between the two columns is your decimal. Yeah, it doesn't matter. That's why you can do decimal on the abacus, because it doesn't matter. One row equaling 9 is why it reminds me of ASL. Oh yeah, would really get it. Yeah. Yeah, and that's the thing, right? Like the coolest thing about this is you could supertize it, right? You can't really supertize this. These are 10, right? One, okay, that's fine. But if you have a bunch of them, I have to count it out. 1, 2, 3, 4, 5, 6. 6. I have 6. Or you break it up into 3 and 3, then you know you got 6. But here, I could supertize. If I want 6, I do 6. I know that's 6. This is 6. This is 6. They're all 6. It doesn't matter, right? It just matters where we are on the column. This is 600. Make sense? Oh, yeah. Yeah, 600. You know, Lofty, what I was going to say, if you want this one to be your ones, that would be your 6, right? Or if this is my ones, then it would be 6,000. So it doesn't really matter. You just choose whatever indicator that you want. The indicator itself is not the decimal. The indicator is only for ones. That's how I see it. So yeah. Oh yeah. So after the preschool one, the way I had it was after the preschool one, the second one after that would be understanding how to add the 5. When you add the 5, that's where in school we start teaching the kids how to make a 5. But that's as far as it goes. But in Abacus, we make our numbers work for us. We make the numbers work because we don't like our numbers to be freeloading. That's what it is. I wanted to say they were freeloaders. I didn't want them to be freeloading. So what we did is we get them to utilize them. To utilize them is what these formulas are. So this is the formula, right? The formula is plus the 4 is equal to plus the 5 minus the 1. How do I know? Well, this is where the story comes in. I added a little story because sometimes the kids didn't understand, because depending on where they were at. And I was thinking that the kids were young if they were doing from preschool. So my thought was, if I wanted to add the 2, I'm going to add the 2, and I want to add the 4. When I add the 4, there's not enough. You go to the cats in the tree. This is the cats in the tree. That's the tree. They go to the cats in the tree. There's 5 cats in the tree, but 5 is too much. They grab 4 cats. 1 cat runs away. So 1 cat runs away. When 1 cat runs away, it leaves me with my answer. My answer is now 6. Yeah. So then after that, right, it's the same thing. We do 3. And then 3, I want to add the 4. Go to the cats in the tree, right? There's not enough beads to add, so we have to go to the cats in the tree. When we go to the cats to the tree, we grab 4 cats. 1 cat runs away. So 1 cat runs away. And that's how I was trying to explain how to do this. And I think the story helps the kids. I have a couple of students that has gone through it, and it helped him understand, this part. He doesn't quite understand why, because he's only 5. Like, it doesn't matter, right? But for us as adults, I want to tell you why, so then it makes sense to us. Because I feel like as adults, we need to know why in order to understand what we're trying to do. There's always a reason why we're doing something in Abacus. So the question is always, do you have enough beads? If not, how else can you do it? Make sense? So again, we do the 4. We want to add the 4. There's not enough beads to add the 4. What do? Well, we go to the cats in the tree. Go to the cats in the tree, grab 5 cats. Grab 4 cats. 1 cat runs away. 1 cat runs away, and my answer is 8. So then after that, there's the minus 5, and after the minus 5, there's the plus 10s. So then we have a plus 10s. That's what this is. So the plus 10s. After the plus 10s, the reason why I do that is because the camera Hope it seems like the camera's better now. Okay, so after the plus tens, it's the same thing. We need to understand how to make a 10. Which book do you recommend for my nieces that's grade 3 or grade 4? They would still have to start from learning how to. So if you want to go to the TPT, I would probably start with the adding the simple adding and subtracting that was like in here. That's part of this, but you can just take the back part of it if that makes sense. And what it'd be, it would start them into understanding how to move the beads. So this is 9 and we need to take away 3. So this is 9, take away 3, and so my answer is 6. If they are open to understanding something new, then that's where I would start. And then after that, I'd have them understand. I would have to go to plus the 5, and then minus the 5, and then plus the 10, and then minus the 10. It would take them. It wouldn't take them that long, because they're older. But it also depends if they have any homework, and it also depends if you need more. You need more practice. But that's what I would do if that made sense. I would thinking, yeah, go to the TPT. You don't need to buy the whole book. I wouldn't buy the whole book. What I would buy would be the last 4 chapters, which is plus and minus 5. Plus 5, I'm sorry. Plus 1 to 4 is one set, is one lesson. That's a thumb up. I don't know if you can see that. I don't know if I have to go back to see if I labeled it this way. But I would start with that because, and then since you know how to read the abacus, teach them how to read the abacus first before you start doing the adding and subtracting. Then after you do adding, subtracting plus 1, I'm sorry, add 1 to 4, and then there's subtraction 1 to 4, and then there's adding 5 to 9, and then there's subtraction 5 to 9. So there's 4 sets. There's 4 little booklets you can get. I guess what I could do is break it up and have that as a separate thing. I didn't think about that, but I'll probably do that. And then after they know their plus 5, after they know they're simple, then I would go into getting this book. This is more versatile. And then that's where they could do the adding 5 and the minus 5. And then from there, after they do the plus 5, there will be a minus 5. And then after minus 5, then it would be the plus 10s. And that would be the path. And then after that, after the plus 10s, is the 2-step equation. And then after the 2-step equation would be multiplication and division. The reason why is because they need to memorize their multiplication fact. And if they don't know their multiplication fact, then what we could do is, I have add-ins. So what we do is we do cumulative add-ins. I don't know if you, like, if we were to do, easy, right? It would be like 4 plus 4 plus 4 plus 4. This is 4 times 4. But sometimes kids don't know their times table. So what I would do is I would have them work it out on the abacus. So it'd be 4 and then add another 4. Notice I don't have enough beads. This is a plus 5 formula. So it's plus the 5 minus the 1. So my answer is 8, right? So this is 2. And I would have them write it out. 2 times 4. And then if I have one more 4 and then add another 4, I don't have enough beads to add the 4. I need to plus the 10 minus the 6. So my answer is 12. This would be 3 times 4. So it's a little cumbersome, but I think this way will help them understand to do their multiplication. And then let's say they don't, and then after that they do another 4, right? This is 4 times 4. So they add another 4, and that's 16. And so it's 16. But see, the thing is let's say they don't remember what 3 times 4 is, but they remember what 4 times 4 is. Then they will know that all they have to do is take away, the 4 to get to 12. Does that make sense? So I like this way just so then they can add and subtract as they need to. If they don't remember all of their multiplication, all their multiplication facts. Thank you for the follow. Did that make sense? Hi, Sun Lady. Wow, there's still 14 people here. I'm just babbling about multiplication, but that's what I do. So I do have one where we have like the 3 times table, and I'm gonna go to 12 because Mainstream math does 12, but Abacus, we only go up to 9. Yeah. And I know we were taught to memorize, but I actually didn't know this until I started trying to make my own worksheets. So this makes sense to me because I still think of it this way. Like I remember 6 times 6 is 36, but then I'm like, oh, if I want to do 6 times 7, I'd be like, okay, if 6 times 6 is 36, add another 6, then I know I have 6 times 7, and that's 42. So it's easy to anchor off something, whatever you remember, right? Like I remember 7 times 3 is 63, but if I want to know what 7 times 8 is, I have to just take away the 7 and then be like, oh, right, it's 56. But it takes me a little bit, you know? There's just some multiplication facts that kind of still trips me up a little bit. So I just go back to, doing this, and then if I know how one of them is, then I just add what I need. That's it. So here is my plus 10s. So adding the plus 10s, again, it's just like how we make a 5, we're going to make a 10. We know that we have 4 plus 6 is equal to 10. Four plus 6 is equal to 10. Well, why is that going to matter? Well, it matters when we want to well, let's do 5. 5's easier. 5's the easiest, right? 5's always easy. So if we do this one, we'll do 5 plus 5. So what we do is we need to isolate the variable. We know how to isolate the variable. Again, we isolate the variable. It's plus the 5 is equal to plus the 10 minus the 5. Why are we going to do that? Well, if I did 8, let me see if I can find it. No, that's 6. Oh, here it is. So if I did 8, no, that's 4. Oh, sorry. Here we go, 5. Yeah, so we did 8. So the question is 8. I add 8, but I want to add 5. We already have a 5 here. Any recommendations for adults who want to learn Abacus? Destiny? Yeah. I'm working on it. That's the recommendation. It would be the same. Understand how to move the beads. If you know how to move the beads, then I would probably go into the how to make a 5. How to make a 5. I'd probably do that first because it's easy to know, right? It's easy to see that this is 3 and then I add 5. So I think the adults, they don't need to know how to do this. But I think, understanding how to make a 5, I think would be better. So maybe the adults would start with how to make a 5. And then they go into like how to make a 10. Did that make sense, Destiny? Sorry. Can you send Peppermint down? Okay. Why? She's sleeping. Sorry, just answering. She's sleeping. She is sleeping. Okay. So we're back to here. 8. So I want to add the 8. Because we add the 8, we want to plus the 5. When we want to plus the 5, if we look, we did it here. Plus the 5 is equal to plus the 10 minus the 5. So we plus the 10. Plussing the 10 only means going to the next column over. Plus the 10 and then minus the 5. That's what that is. Yeah. Okay. Hold on. Hold, please. I gotta let my dog out. Okay. Go. Okay. I'm back. All right. Sorry about that. Okay. So plussing the 10. So then what's going to happen is understand that what we just did is a carry over. We did a carry over and it happens already as part of Abacus. And then we also do borrowing. I need to go to bed. Thanks for the math. Yeah, thank you, Eve. Not a problem. I'll be here for a little bit longer. And then it'll be time for me to go to bed too. All right. So what's going to happen is, so we did the 8. So we added the 8, but notice all I have to do when we add the 5 is plus the 5 is plus the 10 minus the 5. So I plus the 10 minus the 5. And my answer is 13. Yeah. And so that is about That is about how to add a 10. So then the next one would be how to take away the 10. So if we take away the 10, I will go here. And I need to do this. So if we minus, let's do 12 minus 8. Again, how do we do it? Well, we have 12 plus 1 and 2, right? And we take away the 8. Notice the 8 is here. We cannot take away the 8. But to take away the 8, our formula is, where's our formula? Minus the 8 is minus the 10 plus the 2. So I'm going to minus the 10 plus the 2. That's what this is. So we're going to substitute that. I'm going to take away the 10 and then plus the 2. So my answer is 4. And that's it. That's it. Anybody have any questions? Huh. Okay, so I have to write down the answer. 4. The answer is 4. Yeah. So Crafty Mom, I don't know if you're still here. Is that all right? This is great for visual learners. I believe this is great for all learners, really. Where can I get the same abacus? I sell this one on my website. You could get it on my website, or you can get it on Amazon. If you want, you want to DM me, I can give you the different recommendations. Yeah, not a problem. The one thing is this one might be depending on how many numbers you get, it won't. I can't find my website. Oh, I could not. Oh, it's in my link in my bio. The link in my bio. That should take you straight to my website, and then there should be a picture of the abacus, and it's 7, but it's 7 columns, and so this would be good for, I think, maybe up to 4th grade. 5th grade would be a little bit hairy, I think, just because they get bigger numbers. I don't know how many numbers they go up to for I could not find your website. Yeah, I don't know how. I still have to figure out. I was going to build a curriculum, abacus driven, for each grade. I just have to figure out like the numbers and the digits that they're working with. But see, once they understand the fundamentals of the formulas, then it'll be easy. It'll just be bigger numbers. And so that's what I was thinking, and trying to figure that out. But it's going to be it will take a little bit more research on my end to try to figure out how to like get it to coincide with, let's say, Common Core stuff, because there's like Common Core, like understanding how to add and subtract, the plus 10s or the 5s or the 20s or whatever, count to 20 or whatever. So that was one of the things, to try to incorporate all of the Common Core standards into the abacus. And I know it's possible. It's just time consuming. So yeah. Did you find it? So does anybody have any other questions about abacus, or any other arithmetic, or where did it come from? Haha. Sapphire lost. Gaming! You lost the game, Sapphire. No! Sorry. We're just talking about the abacus. If you want to know how to read the abacus, we could talk about it again, right? So how to read the abacus, it's 1, 2, 3, 4, and then we have 5, 6, 7, 8, 9. Notice all these beads are touching. Could you start to the far right? You could, but I don't like to, because this is my indicator. My indicator is my 1s, and then if you were to use this as money, then you would have your decimal. And you would have your your digits, right? Just like you would have money. So if this is 5, if this is 5, we could do 10 cents. This would be 1 and 10. I'm sorry, 5 and 5.10, right? If you did 1 penny, that's what 1 penny would look like. That's why I would keep it here. And that's why I use my indicator as my ones. If I had the 13 column one, the decimal, the indicator is all the way to the right. So you could do that. But I usually use the indicator as my ones. It's just easier, so then I don't have to remember if the numbers get bigger, I don't have to remember where I started. I know that my indicator is always going to be my ones. Did that make sense? And so that's why I don't start to the very end. And I don't start right in the middle, because even in the middle, there's no indicator. So that's why I would always start on always start on the dot indicator to label it. Yeah. Just to keep track, because when you do a lot of abacus, it gets a little mind numbing. It gets a little mind numbing to do a lot of math, like a lot of number questions. And so you want to keep track of where you are. And so that's why I would use the indicators for what it is. Yeah. I Abacus makes everything into manageable chunks. So when we do multiplication and division, you could do it on the abacus. I would use the 13 column one, because when you get higher in the multiplication, the questions get bigger. So as the questions get bigger, you want to be able to house all of your numbers on the abacus. The abacus is meant to track your numbers. You actually do the calculations in your head, which is interesting. I didn't think that, I didn't think it was more to it, but that's all it is. The abacus just helps you track your numbers. That's all it does. And you actually do like the adding and subtracting. You just need to move the numbers as it goes. Like say with this multiplication question, right? This multiplication, I actually did this in my head. And then I just put the numbers, I put the answer, I put the product on the abacus. That's all I did. And when I put the product on the abacus, then it gave me the answer. So abacus makes it into manageable chunks. Yeah. Wow, there's still 8 people here. So yeah, yeah. I guess what I could do. Scary Terry joined. Hello, Scary Terry. Crafty Mom, do you have? I don't know if you're still here. If you had any questions about anything, but yeah, anything about abacus. It's just interesting. Like I wish my kids, all my boys know it. They appreciate it. They won't see until they have kids the benefit that I gave to them. I live vicariously through them. But that's what we do, right? We live vicariously through our children. I just wish they played the piano or some sort of musical instrument. And then I wish that they were all lifeguards. Because I wish I was a lifeguard. But I didn't. I was too young to be one. Anyways. So if anybody has any questions, hello, CJ Holmes. Thank you for the like. And Chucky. Ooh, 75. 745. So 745 is 745. How do I know? Because this is my ones, my tens, my hundreds. I do 745. 7, because the top beat is always as a value of 5. So we have 5, 6, 7. And then we have 4. 1, 2, 3, 4. And then this is 5. Because this is a value of 5. Anytime the beads are touching the horizontal bar, we're tracking it. The horizontal bar tracks our numbers. Yeah. Okay. Anybody have any questions? Else, we could do some more math questions if that made sense. I know there's a few others, and that's the thing. Like the one thing, but don't understand though, when you understand these four basic formulas, now it depends on how you integrate it. It's like Tetris. How can you make one fit into another? And then that's when you get into a two-step equation. We can get into a two-step equation, but it is a little bit more involved, and I don't want to scare anybody, if that makes sense. But yeah, what we started off with was understanding how to add a 5 and subtract a 5, right? When you understand how to do that, then you can go into how to add a 10 and subtract a 10. And that's why these little flippy thingies are. And then there's a vertical one. I started a vertical one. The vertical one is just to help do a reminder. But yeah. And then, yeah, and then I'm just building out some more worksheets and stuff. Oh. Hold, please. I need to verify that I'm still here. But if there's nothing else, I am going to sign off. It's getting kind of late. 10:23 on a Friday. Thank you guys for staying over and mathing with me. Midnight math. Yeah, I'm on often. And this dog. All right. So if there's no other questions, I will see everybody in my next live. Thank you. That was awesome. Oh, hey, you're here. Yeah. No, thank you. Thank you for joining. Thank you for being a part of my live. Let me know if you have any more questions, and I will see you guys all in my next live. Thank you so much. And have a good night. Hello, BK. Good night, BK. I am about to pass out. Was there any last minute questions, BK, before you had a question? Before I leave? I was about to leave. Do you have any specific questions? Don't be sad. Do you have any specific questions? Do you want to know how to read the abacus? Is that what you want to do? We can read the abacus. I'll be here next time. Oh, okay. I'll be here too. I'm here pretty often. I think I've been doing at least twice a day so far. I was thinking about upping it to, I don't know, 3 times a day. But it all depends if I can get some work done. Trying to get some... I've been needing to learn how to... I read to learn how to finger thing. What are you doing next time? Oh, the finger thing or the abacus thing? Because the abacus thing is easy. I can tell you right now. Wanted to learn how to do the finger thing. I don't know the finger thing. I know the abacus. Are we talking about the abacus? We do it right now. 1, 2, 3, 4. Anytime the beads are touching this horizontal bar is our tracking. Tracks our horizontal bar. The horizontal bar tracks 4. All the top bead will be 5 no matter what. 5, 5, 5. 5, 5, 5, 5, 5. That's it. So then after 5, 6, 7, 8, 9. After 9, there's 10. 10 is this one over. Just like how we have our place value. That's it. So when we look at it, this is 9. This is 10. 11, 12, 13, 14, and then 15. Is that what you're talking about? So if we look at it, there's my tens, my ones, my tens, my hundreds, my thousands, my 10,000. So the reason why I'm here is because my indicator is here. My indicator, you just choose one, just like Pokemon, you just choose one. So if I showed you this, right? 9,215. 9,215. That's it. And then anything after the ones is my decimals. After anything in my ones is decimals. So because the decimals sits between the 2 columns, right? It sits between 2 columns. It sits right here. So here I could do 75. What is it? 5? 9,215.75. And that's it. That's how you read the abacus. Easy. Simple to use. Easy to understand. There's nothing to it. That's so cool. I didn't know you could do decimal points. Yeah, you can do decimal points. So you could do adding, subtraction, multiplication, division. Yep. Is it faster than mental math with your expertise? The idea for abacus is to go to mental math. Can I do it? No, I learned abacus later in life, so it takes me a little bit. Like I can kind of see some things, but I don't do mental math. Division, that's crazy. Yeah. My kids, can they do mental math? I didn't push them to do mental math. It is a skill to do mental math, but they have a pretty strong sense of number. They have a really strong number fluency and number flexibility and number sense. But I didn't push them to go into mental math. But you can. There's a whole bunch of abacus competitions, but those are the things I didn't really push my kids to do. And so I don't I don't get them to like just crunch out the numbers, but you can. It is possible. I know that's one of the big things is to go mental math, and I'm like, yeah, Abacus has been around for Abacus has been around, and even with like the Chinese abacus, with the old Chinese people, they still use the abacus for what it is. They don't push everybody straight to mental math. Does that make sense? So it's kind of cool. Like it grows with you and it never leaves. Abacus never leaves. So the idea is to utilize it for what it is, and it's a tool to help you track numbers. You could go mental math if you can imagine the abacus in your mind, but if you can't, then use the abacus as the tool for what it is, if that makes sense. But yeah, I don't really push my kids to do mental. Okay. Thank you, BK, for joining. Of course, not a problem. That was the quickest how to count on the abacus. Join me next time. We will probably do well. Join me next time. We'll do adding, subtraction, multiplication, and division. It all depends on the group of people. It depends on how class goes. So have a good night. Thank you for asking. Thank you for the comments, and I will see you in the next live. Bye. See you later, Destiny. Yeah, you're welcome.